Hey everyone, welcome again to my channel. Today we will discuss one algorithm known as Kadane algorithm, which is used to find maximum sum of a subarray. So what is the problem statement? We will see next. So there is an array given to me where the array is filled with negative and positive numbers. So we have to find what is the maximum sum of a subarray present in this main array. So generally if it is a filled with means positive numbers only, then we all know like from 0 to 9 every digit we have to add up, then it will give me the maximum sum of a subarray. But as negative numbers are present in between, that's why that negative numbers will contribute negatively in the total sum and it can decrease the sum. So that's why maybe from here to here, from 0 to 3, the sum will be less compared to 5 to 8, because there we can see more positive numbers are there and they are bigger numbers. Okay. Or maybe two bigger numbers only can contribute more than 5 or 6 numbers where positive and negative numbers are mixed, or maybe positive numbers what is present, these are less numbers. So to find like what is the maximum window we can get where the sum of these numbers will be maximum, for that purpose Kadane algorithm is used. So how to find out that, we will see now. So to find out that thing we need two variables. One is max sum till now and another thing is max sum in current window. Okay. So what is max sum till now? So before that I will talk about what is max sum in current window. So when actually we will solve this problem, what we can do is from 0 we can start and then we can proceed to our right side and add one by one numbers. So when I am adding one by one numbers, that means one window is going on and that summation I am tracking in this variable called maximum sum in current window. When I can see that the summation is negative or less than 0, that means that window we have to discard, means that window can't contribute more to us. So that time what we can do is we can start from fresh. From there we can make the maximum sum in current window as 0 and then we can start from there and we can start a new window. And if that new window has a maximum value greater than the previous maximum sum till now, then we can replace that thing. And at the end, by doing this thing, we can get the maximum sum in a subarray. So two things we have to do. One thing is, if in a sub window whatever maximum sum we will get, if that is greater than the previous maximum sum till now, then we can simply replace this maximum sum till now as the current window sum. And another important thing is, if the maximum sum in current window means what, whenever actually we are calculating the maximum sum in a current window, if that is by chance negative, then we can make it as 0 and start a new window from there. So suppose in this case, if I see from 5 I am proceeding, then when I reach to 1, that time my sum became 3, because 5 plus minus 2 is 3. Then from 1 to 2 when I went, then 3 plus 3 became 6. So till now my sum is 6. So then I moved here to index 3 position, then 6 added with minus 7, so that became minus 1. So here actually in that window the sum became negative. That means we no need to proceed further because it is already negative. So this part of the sum will not contribute me anymore. So we can do a fresh start from here. Okay. So we can maybe do a fresh start from here. And the maximum sum I can denote till now is 6. Okay. So that way if we proceed, at the end we will get the result. So I will go to the programming section. So before that, maybe it can come into our mind like where it can be used. So there are so many biological calculations or anywhere where we can see some pattern and we can see like, oh, in this area I can see some maximum sedimentation of something, or maybe in a image recognition we can see like this area, particular area, the brightness is more or it is more dark. So for so many analysis, maybe in our chemical or biological anywhere, it can be used. So there is another problem in cadence algorithm only where it is applicable for two-dimension matrix. Okay, so here what I have seen, that is for a single dimensional array. Okay, so there that will be two-dimensional array. So there it will be a 2D matrix and we have to find one area where the sum is maximum. So that is a different problem. I will make a separate video for that. So now for cadence algorithm for single dimensional array, we will do the programming. Okay, so let's jump into the programming part. So here I have taken one class called cadence algo, and there I have defined the main method where I am taking this array as input. This is the same array which I shown, and I have defined one method which called maximum subarray sum, and there I am passing this array. Okay, and here only in this method I will print the maximum sum. Okay, so as I discussed, I can define two variables. What is maximum sum till now? I can initially manage it with the first value of the array at the beginning. Then I can define another variable called maximum sum in current window, and that I can define as 0. Then what I can do is I can create a for loop here, there, from integer equal to 0 to I less than equal to this array dot length I plus plus. So here I am going or looping through the main array, and first thing what I am doing, current window I am proceeding and adding one by one value. So maximum current window value will be array of I. So the current window, there I am proceeding and adding one by one values, and I am checking. I will take some space from here, and I am checking if this maximum sum current window is greater than this maximum sum till now, then I will replace this maximum till now to this maximum current window value. Okay, because then the next bigger maximum sum till now will be the current window if it is bigger. And if I see by chance this maximum current window value become negative or less than 0, that time I have to do a fresh start. So that time what I have to do is I have to make it 0 again, and from there I have to do a fresh start. Okay, so this is all about this program, and at the end what I can do is I will print this result. So max sum I can print as this maximum sum till now. So if I now run this program, so I am getting the result as 24. So if you check here manually also, the maximum sum you will get, I think, in this part. 11 plus minus 2, that means it will become 9. 9 plus 7, so it will become 16. 16 plus 8, 24. So apart from anywhere, if you check, I think the value will be less. Okay. So the maximum sum of a subarray, what we can get is 24 from this. So now maybe another variation of the same problem can come where it will be asked to print the starting and ending index also of that particular window. As I mentioned, like it will means as per uh, my thinking that it will be from 11 to 8. But if I have to print like what will be the start index and the end index, that also we can do here. So to do that, what I can do is I can define one variable called start and another is end. Okay, and another I need actually that will called shift. Okay, so 3 are initialized to 0. So now we have to do one thing, that is so when things are changing, so when actually the maximum sum in a current window is going into negative, that time the window is shifting. So this shift thing I can mention as I plus 1, because from what is the current I, next to that from there the new window will start. So shift will be I plus 1, and when the maximum current sum is replacing the sum till now, that time what is happening is that time we can shift the start to shift and end will be till then only, that is I. Okay, so now I have printed all those things, so start and end index. So if I run now, yeah, we can check is the start index is 5 and end index is 8 for this maximum sum. So if we go there, the 5 index means 0, 1, 2, 3, 4, 5. So from here it is starting, then 5, 6, 7, 8. So this is the portion, this is the subarray portion which is giving me the result as 24, the maximum sum, and the index range is from 5 to 8. So before ending this video, one thing we will quickly check, that is if this algorithm is working for negative numbers or not. Suppose one array is there where all the numbers are negative numbers only. So that time it is working or not, we have to check. So if you check here, the result is -3. So if you add any negative number with another negative number, it will become more negative. Okay, so if you see here, in case of all the numbers are negative, that means which is close to 0, that will be the result, because that is the only highest number here. So the highest number here is -3 and that will be the result. And if we check the result, that is only showing. And index is 1 to 1 because that is the only position. So if I introduce one 0 here, then what will be the result? So expected result is 0 only because that is the maximum number here, and if we add the 0 with any other number, that will become negative only. So it will reduce the sum. So if I run it, so the answer is 0 and the index position of 0 is 3. So it is working for negative numbers also. So now thanks for watching this video. I will put this programming link in the description box and share with you guys. And if you have any comments and doubt, please mention it. Thanks for watching.